So thank you for having me. I'm Daniel Suchý, and today I will be speaking about Static Hermes and not only. So before we dive into Hermes, we need to understand how browser engines works, because then you can appreciate how it is done in Hermes. And I also think it will be beneficial for people that are not into the React Native to get known browser internals a little bit better. So yeah, this nice diagram right for the beginning. This is basically how your JavaScript code from your editor gets into the user's computer and gets executed. We have it divided to two parts. Basically, the left part, it's a build time. It's what's happening on your computer or at the CI/CD pipeline. And the right side, it's what must happen on the user computer in order to get the code executed. So let's start at the beginning. We have this first box. This is a JavaScript source, TypeScript, or whatever you use, and can be compiled into JavaScript. Then we transpile it, minify, and we are ready to ship this bundle to users. And now we are getting to the runtime part. First thing is something called lexical analysis, also tokenization. This is basically going through code and parsing it into tokens like function, for, const, while, and so on. Then we take these tokens and parse them into abstract syntax tree, which is a tree-like structure to represent your code, which is like good for computer to work with. And when we have this abstract tree ready, we can start something that is called bytecode generation. Before we get into that, I think I should explain what bytecode is first. So on this diagram, you can see some simple JavaScript code on the left. This is code that we all like to write. It's easy to read, super simple. On the opposite, on the right side, is a code that is like great for the machines, and it's not that much readable. It's also very hard to write, and bytecode stands somewhere between. It's like intermediate representation of your JavaScript code inside the JavaScript engine. Why does engine do this? It's because it's easier to work with this bytecode than like any other formats. It's also faster. It can do some optimizations. It can do some analysis easier from it, and so on. Also, one important thing about this bytecode, that this bytecode is like internal thing of the JavaScript engine, and is specific per engine. So V8 from the Chrome will have different bytecode than JSC from Safari, and different from the Hermes, and it can even differ between the versions. The same is for the machine code. Machine code is specific for the CPU platform. So let's go back to this diagram. We now know what the bytecode is, at least I hope. And from this bytecode, we have unoptimized bytecode, which is basically like just compiled JavaScript to this bytecode. You can perform some optimization on it, but we will get to it later. And now when we have bytecode, we can execute it. And this is actually where if you stop, it will work. And but this is not where the most today's browsers ends. There is also something called JIT, which is just-in-time compilation, and we will get into it in a moment. So yeah, so this is like the basic part. You can see quite a lot of things is happening during the runtime, including these complicated JIT boxes, and I will explain them right now. So what it is, JIT, aka just-in-time compilation, will make your code run faster by guessing types during runtime. Here is a very simple function that will add two numbers, and you can see first call of this function is with the numbers. So JIT may pick it up and it will guess, okay, so user or whatever is using this code is want to use it only with numbers, so I can optimize it. How does this work? It will generate the machine code that is optimized for adding two numbers, and this machine code that is optimized for numbers could be much shorter than and should contain much less instruction than the code that is used for version without JIT. As you can see, even this simple function is like 300 machine code instruction. It's like super simple function, and in JavaScript it needs probably about 300 instructions. I can say for sure because it's different again per machine, per architecture, and so on. Why it is so slow? Basically, because more instructions mean slow. It is because the JavaScript is super dynamic language. Most of these instructions are some checks if you are not doing some crazy stuff like adding number and object, or adding or for example subtracting string from the array, and so on. And all this crazy stuff can happen, and this is because this is a reason why JavaScript is slow. So JIT is here to solve it, and it will try to guess what are you trying to do with the code and make it faster. But you will run it, it will optimize it, and then someone decides, okay, this is I will use this function for example, I don't know, putting the string into it. It will work in JavaScript. I don't know what it will even do, but it will work. And in that moment, it will break that optimization, and JavaScript engine will be like, okay, so maybe there is not always numbers, so I need to fall back to a slower variant. So this is something you need to think of when you are designing your code. You may have some utility functions that are using in different contexts, but with different types, and sometimes it may be better to have like two functions but use them in different contexts. But it always depends. JIT is super complicated. It's very smart, so sometimes you might figure out there are two versions, so it will be still fast enough, and so on. So how to know it? Measure it. You need to profile your code, and then you will know for sure. But again, it will behave differently in every browser. So yeah. Also, one important thing: the browser will probably not optimize this after first call. JIT is quite expensive operation, so browser needs to be sure that it's worth it. So, for example, it may happen after 10th call or after 100th call of this function and so on. So that's also one kind of uncertain things. This is one more example that could be like quite common. You have like two arrays and you have functions to sum them. In the first array, there are only numbers. In the second array, there is one number that is basically written as string. This string might trigger the optimization of the sum array function on the JIT side, and it may make it much slower. But again, it may, because it's a JIT, it's super complex, and you never know until you measure. Another kind of common mistake that you can do is having the object with slightly different shapes. For example, you have some function process that will add the value 10 to property value. It will work for both these objects, but the second one have extra property, and this extra property may trigger the optimization. But again, it depends on the engine, it depends on many things, because JIT is complex. So again, measure it if you want to be sure. So now when we know how browser process the code, we may take a look into Hermes. Hermes is a JavaScript engine for the React Native. It's optimized for mobile devices, so it has reduced runtime resources consumption, and probably like the reason why it was even created is that it has extremely fast startup times. Before the Hermes, the React Native used JSC, which is engine from the Safari, from the Apple. And there was like common startup time was more than 3 seconds. 5 seconds was not an issue for a big app. So this is the reason why Hermes was created. And to understand why it was slow in the first place, let's look at this standard JS engine diagram again. You can see basically now this is like client side, and this is happening on every user's device when the code is loaded. And you can imagine, even if this is fast, if you have like 10 megabytes or 20 megabytes bundle for app, which is not uncommon in React Native, it may take a while. And this must happen before the app startup. So how Hermes solved this? Hermes moved the line much more on the right side. You can see this is the same, your JavaScript code, TypeScript, transpile, minify, lexic analysis, AST. Bytecode generation is happening like during the build time. This produces some unoptimized bytecode. Hermes will do even some optimization on that bytecode before it's sent to client, like object origin and inlining of some functions. I will have link to some videos where this is explained better and more detailed. And then it loads bytecode bundle, and it doesn't even load the whole bytecode bundle. It loads only the parts that are needed to execute app, and the rest is loaded on the fly. So it's like super efficient in this manner. And it resulted to significant reduction of startup times for many mobile apps. It's like common startup time today is like something between 1 to 2 seconds compared to, for example, 5. So it's really, really good. So yeah, that is Hermes. This is version that we used for a while now, but now we have new version on the horizon. It's called Static Hermes. You can probably, it was introduced like 2 years ago at React Universe. It's not released yet. It introduces a few new features, and some of them was backported to the current version, so you can use them in the latest version of the React Native, even if you don't use if you don't use Static Hermes. One of them is runtime bytecode translations. This is something like JIT for the Hermes, because Hermes doesn't have JIT, because JIT is very complex to write, and Hermes team is very small, so they did not have capacity to do that. They now introduces some very simple version. I will show it in a moment. If you use Static Hermes right now, you will have a little bit faster startup times. You will finally get native support for S6 classes, which is nice because it's 2025. It has type mode. I will get into this later because it's very exciting. And it's also possible to compile the code into the bytecode or into the native binary directly. So there is like not even the bytecode step, it's just get executed, but it has some disadvantages. I will get to this also later. And a lot of other improvements, not only performance. So about bytecode translation, it's a very simple version of the JIT. It basically like creates machine code for the slow and for the fast part in the code. It will basically try to guess which could be fast part, which could be slow. For example, fast part here could be like adding 2 numbers and in some function, and slow part could be like adding string and array together. It's simple like this. If the check for the fast part fails, it will just do slow part, and that's it. It's Android only, like everything JIT related, because JIT is generating machine code runtime, which is not allowed on iOS. But it's not that a big issue because iOS is quite fast anyway. And it's, as I said, backported to the current version of Hermes. Another quite exciting thing is type mode and native compilation. As I said, JavaScript is slow because it's super dynamic, and it has to run significant number of instruction, significantly higher number of instruction, because it needs to do all the checks. And in the end, machine instructions is what matter and what make it fast or slow. Type mode is trying to utilize that we write our code in TypeScript anyway, so we doesn't know if value will be number or string in advance. So if you know the type beforehand in the build time, you need to like omit most of the checks and just go with the fast part. This is like very exciting because if you combine it with like native machine code output directly, so you don't even have bytecode, you just produce one executable that is in machine code and that's it, you can theoretically get to the speed of C++, theoretically. Practically, it's not that good. I've seen some benchmark that is proving it. I've seen some benchmark that is not proving it. It's kind of hard because it's very easy to write slow code in C++, and you don't know what to believe. But theoretically, if you know the types in advance, you can generate the machine code just for the adding two numbers. So it's like few instructions and some check, because in JavaScript you can never rely on anything. We are almost there, but not really. There is few issues. First of all of our pipelines are built to strip types away. That's an issue. There is like currently no way how to transpile your code and keep your types in a place so you can feed it into Hermes. Type mode works for relatively simple examples and benchmarks yet. It's not even too possible compile React Native with it. Solution could be partial adoption, so you will basically identify the slow hotspots in your code and migrate only these functions to type mode. It's something that might make it significantly easier and faster to adopt, but we will see. And the last part is probably weakest part of the Hermes. There is no documentation, like really nothing. You can basically, every information that I have is from the talks or from the X profile of the Hermes development lead, Svetan. I really recommend you to follow this guy. It's really amazing. But it's basically like best source of any information about Hermes, because there is nothing. So yeah, there is also some benchmark from the last talk from Svetan. You can see like normal Hermes that we use today as a baseline is 1. Then we have untype static Hermes, which is basically like that simple JIT that I showed you enabled is like 2 times faster than the baseline. Then you have typed bytecode output, which is like 8 times, 4 times faster. It depends on the benchmark. And then you have like native typed, like fully super fast. What can Hermes do? And you can see like 12 times faster than the baseline, which is kind of nice, but it's still a benchmark, and we will have to see how it performs in the real world once it's available. And about that, Hermes team made some promises that it will be available this year. I'm not so optimistic, but fingers crossed. How can you try it? You can actually try it, Static Hermes right now in your app. It's not even that hard. There is a fork from Software Mention, and there are like pre-built binaries of the Static Hermes and simple patch for React Native that will use these binaries instead of normal Hermes. But this is like Static Hermes without type mode. So it's just like a little bit better version of Hermes, but not that fancy stuff we are looking for right now. But definitely it's worth checking. I tried it in one of my apps and it just worked. It was a little bit faster, but not that much. And the second option is to build it from source. You can do that, and you can even run it on your computer. This is engine for the React Native, but you can run it anywhere. And maybe in the future, when the type mode will work, it might be it might be really beneficial to run it, for example, on some server, because you will want like super C++ like performance if it will work like they promise. So that's one of my thoughts. So this is the sum of the resources I put together. This is basically all you can find about the Hermes right now. It's like probably best Hermes documentation on the internet right now. So if you want to study, self-study, definitely go there. There's like people to follow, the conference talks, everything that might be interesting. And that's it. Thank you very much. And don't hesitate to ask me any questions about Hermes and whatever you might feel interesting. I'm not like super knowledgeable, but I know something.